So we're logged into our Juniper router here with this sample topology. So again, on the left are JR1, and then Cisco router 1 and Cisco router 2 in a line out towards the right. We just want to have a quick play around with some of the most basic tools that every network engineer loves and knows. So ping, traceroute, telnet, all of that good stuff, and a couple of things that are specific to Juniper as well. All right, let's start with something simple. Maybe we ping our CR1 host loopback, or CR1 router I should say. It doesn't get much easier than that. Output looks a little bit different from what we might know on Cisco. We can make it a little more familiar if we do something like, say, ping rapid. Here we see now, because we're doing it rapid, we don't have a pause between each packet that we're sending. We're just getting exclamation for each success. Let's make that ping rapid count 100 maybe. Just fire out as fast as we can, as our ICMP towards that Cisco router. I mean, if we put question mark at the back end of this, we can see there are a lot of different options we can play with. Many of them very similar to what we know already from Cisco. Do I want to do ping but force a different size? Maybe I want to say size 1000 bytes, or maybe I want to do something like ping source. Now, here, I must admit, I do miss from Cisco the option to be able to include the source interface. But unfortunately, Junos wants us most definitely to specify the source IP address. So I can't type lo0.0. I have to give my own loopback address as the source. So there you go. I mean, that maybe begs the question a moment ago when I ran the same command, more or less. When I pinged that Cisco router, but I didn't specify the source. What would have been my outgoing source address? Junos by default is going to take the primary IP address on the outgoing interface. So when I've run the command again here and forced the source address to my loopback, I am having a slightly different packet exit. Obviously that's quite useful from a troubleshooting point of view to verify return routing to a certain destination, or I should say to a certain source rather. We can ping from that source and get an echo reply back. I mean, maybe we also want to do something like, ping this destination, or again our Cisco router, but force that the fragment flag, or rather the do not fragment flag is set. That's particularly useful if we combine it with a large packet size, because what we're doing now is sending a larger packet, but we're forcing the IP headers do not fragment field to be set. So if we have some kind of MTU problem in line, obviously we can catch that. Nothing new compared to what you'd be doing on a Cisco. And like I said, if we look, lots of different options, even quite funky stuff like bypass routing. Force the ping to go out of this interface we specify after the bypass routing keyword, ignoring our routing table. Maybe we want to specify a particular data pattern to pack in if you've got kind of really strange layer 2 errors. I mean, really kind of going back actually to the days of E1 and T1s here. But in some cases we can have a problem with density of ones, density of zeros on the line. The ability to specify a payload pattern can be quite useful to catch that stuff. Maybe we want to ping from a VRF. If it was Cisco, we'd be ping VRF and specifying where. With Juniper, we're going to leave it pinging the destination, but at the end of the command, we're going to specify the routing instance. So VRF1 fills VRF and launch the ping against the routing table contained within that VRF. Very similar to, or in fact, really exactly the same as forcing it to be run from a VRF Lite or MPLS VRF on a Cisco. And finally, even maybe we want to do a ping IPv6. Simply the same command, but we're just going to specify INET6 before we give our destination and any other applicable options we think are useful. So if ping is one of our best friends, traceroute is also another incredibly valuable tool for network engineers. So let's maybe traceroute over to CR2. So it's a small topology, so we've only got a short list of hops. We can see ourselves immediately heading out towards the 10, 10, 0, 100 interface of CR1. Our TTL expires, we get a reply back, and then eventually a reply from CR2. The interface that arrived on the 4040-101 interface of CR2 as the packet arrives at its destination. So as expected really. You can imagine we also have the option to specify a routing instance here. We can turn off DNS resolution. We can do this for IPv6, IPv4, bypass routing, play with the the source address paired with the quality of service, type of service byte, same with ping as well actually. All of the stuff you would expect. But I just want to show you one other quick variation on that command that's very nice. If we do traceroute monitor and then the same loopback address of the CR2, then we see something very nice. You know, we have traceroute running here, but it's traceroute running over and over again. Some of you might recognize this as a tool taken from the Unix world or Linux world. So MTR, my traceroute, or some people call it Matt's traceroute from the gentleman who developed it originally. But you get the idea. MTR is now basically alias to traceroute monitor and a destination in Junos. And you can see the same traceroute output, but we can see now a cumulative loss statistic. You know, currently 0 loss, how many packets are being sent, you know, what ping times are we getting, what variation in latency and so on. So it's quite nice to leave that running maybe in one window during a maintenance window or when troubleshooting an issue. As you start to make changes, you'll see the traceroute reconfigure, and maybe you'll start to see loss appear or disappear as traffic patterns shift. Remember, particularly if you have a network with equal cost multiple paths, running traceroute just once can occasionally be misleading. You may find that your traffic just happened to be balanced onto the path without a problem the first time you ran traceroute. So instead of running it over and over manually, traceroute monitor here allows us to just sit there watching, dynamically updating what's happening on that path. You know, same as the Cisco, you might want to jump from your router to some other device in the network. You know, so we can telnet, specify a host we're going to telnet to, vary the source port, source address, vary the port we're telnetting to, and even to telnet IPv6 if you want, all of that good stuff. And similar with SSH. Oh, and I should mention, obviously, with both of these, there's always the opportunity to specify the routing instance keyword if we have a VRF, if we have a virtual router in the system, to force the telnet or the SSH to use the forwarding and routing table of that particular instance. In fact, while we're on that note, just a quick reminder, we have discussed routing instances, but if we do something like show OSPF neighbor, we're getting the answer here for the master inet.0 routing instance. We can, at the end of almost all show commands, put show XYZ, in this case show OSPF neighbor, and if we hit question mark again, we find that it's possible to add the instance keyword. And that's why I'm highlighting it. We've just seen with traceroute, with ping, with SSH, with telnet, we use the keyword routing instance and then the table name if we want to forward the traffic from that particular routing table. But now, unfortunately, we see that with many of the show commands, instead of sticking with the same keyword, routing-instance, they've chosen instead to use the keyword instance. It achieves exactly the same thing, just a slight variation in syntax. So, if we show OSPF neighbor, it's instance. Unfortunately, there's a fair bit of inconsistency sometime in the CLI as to whether routing instance or instance is used. So, for example, if we show ISIS adjacency, here it's, again, instance, that's great. But then if we look at something like show interface terse and try an autocomplete instance, it fails. Here it's routing instance. And then one last variation, and this is one's fairly easy to remember. When we do show route, we will see the entire routing table. But if we want to see the routing table of a particular routing instance, a particular VRF or virtual router, we need to specify table and then the instance name. Okay, right now, the only configured instance I have is inet.0, but if I had more, those instance names would be here. So a little bit annoying, but after a short time, you start to get some muscle memory that just instantly reminds you whether you're typing instance or routing instance, or in the case of show route, table. But either way, it's easy with any command to target the correct table for the output.